Every once in a while, a significant web security breach happens. Today, we're diving into popular polyfill incident to explore what happened and the lessons we can draw from it. So let's take a closer look and break it down. But let's start by exploring the sophisticated threats known as dependency chain attacks. These attacks exploit the complex web dependencies in modern software development. Let me ask you this. Have you ever installed an npm package without ever checking its source or reviews? Well, many people do this without realizing the potential risk involved. Imagine having two main branches, creating a new package and infecting an existing package. Both routes leads to the same goal: injecting a malicious code into project's dependency tree. When creating a new package, attackers have several strategies. Trojan horse create a package that looks real but contains hidden malicious code. Then we have typo squatting, which is creating a package with names very similar to popular packages, hoping that developer or user will install them accidentally. Then we have abandoned projects. Some will take advantage of these projects that still are depending on them. And for existing packages, the attack vectors become more diverse. First, we can inject directly to the source by submitting a pull request as a contributor and hide the malicious code within innocent changes. Or we can commit directly if the attacker gains some sort of control of the credentials or uses some sort of social engineering to become a maintainer. Then you can compromise the build system by injecting the malicious code during the package compilation and compromising the build process itself. And in this polyfill example, it manipulated the package download by injecting directly to the CDN, which is kind of replacing the real packages with infected versions by manipulating the download process. And yeah, you can also, for example, run some sort of malicious build script. And lastly, not so popular option, but it can happen, which is inject directly to the repo host, which in this case, if you don't use GitHub, then you might be compromised, or even sometimes GitHub can be compromised as well. So yeah, these attacks can have pretty devastating consequences, such as widespread distribution of malicious code, data theft from infected systems, creation of backdoors, and lastly, potential for large-scale supply chain attacks, which we will discuss now. Let's fast forward to more recent incident. To understand why this is such a big deal, we need to rewind about a decade. Back then, web developers had a pretty major challenge, which is browser compatibility. And polyfill were the solution for this. And polyfill became the go-to service for hosted on CDN that services could easily link to. The internet pretty much exploded recently with news that polyfill was injecting malicious code into websites. But here's the kicker. This wasn't a sudden attack. The problem were brewing for months. Warning signals actually happened back in February when some developers noticed mysterious logging errors tracing back to the polyfill code. The full scope of the problem wasn't yet clear, but now we know that the polyfill domain actually changed hands in February. So for 4 months, this compromised site had access to countless websites around the world. And the potential for data theft and other malicious activities is kind of staggering. But yeah, the polyfill incident serves as a cautionary tale about risks of dependency chain attacks. So, what did we learn? Don't blindly trust public package repos or third-party CDNs. Consider security at every stage, from development to build to deployment. Frequently review your dependencies, build processes, and code sources. Implement strong authentication and access controls for all systems, and keep your practices current with evolving web standards. Okay, if you're a developer or a company, here's some quick tips to protect against those vulnerabilities. Use private repos and build systems whenever possible. Implement strict versioning, pinning for your dependencies. Use tools that can detect and prevent dependency confusion and supply chain attacks. Implement multi-factor authentications for all dev accounts. And audit. Cool. So these sophisticated attacks and incidents are kind of wake-up calls for all entire web dev community. They highlight the need for constant vigilance and the importance of securing every link in your software supply chain. And remember, in modern web development, security is everyone's responsibility, from individual developers to large organizations, and we all play a part in it. So that's it for today, folks. If you're a developer, take this as your cue to audit your entire web dev pipeline. And if you're a web user, stay informed. That's it. And don't forget to like the video and subscribe. See you on the next video. All right? Bye.
In my mind from dawn till night, chasing that bag, gotta get it tight. Robin's in the zone, working till it's right. Fresh lines, clean design, cash flow in sight.